of x is x squared plus 4. The question is, state the range, or the domain, rather, first, and the range of the function. If we look at the function, what the function does is that for any real number given, it squares that real number and adds 4 to it. And if you square any real number, you get another real number. But for that matter, it's positive. And then this. So, the domain of this function is the whole of the set of real numbers. Because there's no real number you cannot square. And then when you add to it, you also get something, which is a real number. So, domain of f is nothing but from negative infinity to 0 union 0 to positive infinity, which is precisely the set of real numbers. So this is the domain of this function. Again, to find the range R of f, if you take any real number here, when you square it, what you get is bigger than or equal to 0. Any number that is bigger than or equal to 0. You also get a number who is bigger than or equal to 0. So accordingly, the range of this function is nothing but the interval 0, plus infinity. So the domain of this function is the whole of R, and the range is 0 to plus infinity. Coincidentally, the example I have here and the one we had previously have the same range. Somebody may be tempted to believe that the range of every real valued function is usually 0 to plus infinity. The answer is no. Make no mistake about that. It's just a coincidence that the two examples I considered eventually get to the same range. So let's look at another function, f. Let me call it g now, so that we don't think all functions must be written with f. So if I consider g defined on R into R again, I know g at x is 1 on x. So here we want to find the domain of f. Notice that for x equals 0, g of x will give us 1 over 0, which is undefined. Because it is undefined, we say that this function is not defined at the point x equal to 0. Outside 0, for any real number you give, we can always take the reciprocal. That means 1 over x is well defined, it makes sense. Therefore, the domain of g is simply the set of real numbers without the singleton 0. So this is the domain of the function g. If you take away 0, for any real number again you give to me, what you get is again a real number except 0. Therefore, the range of the function g is from minus infinity to 0 open, union 0 to plus infinity. So the only element of the set of real numbers missing out here is 0 itself. Therefore, the range of this function is this, and the domain of this function is that. Both the domain of the function and the range of the function, they coincide, but there's no problem about that. So at least we've been able to see a function whose range is different from 0 to plus infinity. That is exactly what the effort I'm making. So we don't put it at the back of our mind that whenever I give a function, the range must be 0, plus infinity. No. This is an example of a function whose range is this. So from here now, we know how to determine the range of a function, determine the domain of the function from the definition of that function. So next video, we will take more examples and then go into types of functions. All right. Thank you for your attention.